Hi, everybody. Thank you so much for clicking on this video. In this video, we will be talking about Fabric data agents. And by the end of this video, you will be able to configure a Fabric data agent in your specific environment. All of that and more. So without any further ado, let's go ahead and get started. So let's look at the use case for this specific Fabric data agent. Here we have a coffee shop. This is my coffee shop. It's called Dev's Coffee Shop. And here we have got the different kinds of coffees that we are selling at our coffee shop. So you're going to see that we have a mocha, we have a latte, we have an Americano, we have a flat white, different kinds of coffee brands. Here I've also created some summary tables, right? That tells us all the different kinds of coffees that we are selling in our shop. And then I've also created a summary table for customer names. These are names of all of our customers. We've got information about location as well. This is a lookup table that tells us where in the US our coffee shops are located at. So we can see that we've got a coffee shop at Chicago, Denver, New York, Austin, all of these locations. Now, what I've done is I have a very simple semantic model, right? We've got our data table and we've got our lookup table with one-to-many relationship. Now, a very simple question that we might be leveraging this semantic model to answer is, what location has the most amount of sales? That's one. What location has the most amount of sales? And what kind of coffee is sold the most at the location with the most amount of sales? Okay. There are two things that we have to identify. The location with the most amount of sales, that's one. And then what kind of coffee is selling the most at that location? Okay. Now, without a Fabric data agent, how would you answer that question? I'll give you like 5 seconds to think about it. You don't have a Fabric data agent. How would you answer this? Did you get it? Without a Fabric data agent, you would obviously have a dashboard, right? This is a more traditional approach wherein you'll have a Power BI report, right, with a bunch of different visuals. Then you'll have a slicer pane, dedicated slicer pane, with a bunch of different visuals, and you'll use those visuals to slice and dice the data. Now, all of this is great, right? Using a dashboard, you can answer these questions. But what if you could just query the semantic model directly, chat with the semantic model and ask it questions, right? So in this case, you'll see in this image, we have got a CEO coming to an analyst and asking questions like, what is the most popular coffee in the North region? Okay. Now, this analyst, even with Power BI, would have to open a dashboard, would have to apply certain slicers, would have to see the most popular coffee in the North region. Probably we're going to apply the slicer specifically for the North region and see a sales metrics and then see the coffee that is tied to the highest amount of sales. However, that's more of a traditional approach, right? We're in 2026 now in the time of AI, right? How would you use a Fabric data agent now to answer a question like this? So in this case, you're going to see that we've got a CEO who is querying the semantic model directly, right? What is the most popular coffee in the North region? Asking that question. And the Fabric data agent queries that semantic model and gives you a response. Now let's go back to our Power BI report. Our question is, what location has the most amount of sales and what kind of coffee was sold the most at the location with the most amount of sales? Okay. Now, we will do it with a traditional approach in Power BI using DAX and visual and slicers, but let's see a more modern way of approaching this, okay? So this data set is already published in a Fabric workspace. So I will just go to that Fabric workspace. You're going to see that I have already published my Power BI report onto a Fabric workspace. So this is my report and this is my semantic model. In this case, our end goal is to make sure that the Fabric data agent can sit on the top of the semantic model and the end user has the ability to query this specific Fabric data agent. So what I'm going to do is I'm going to click on new item, okay? And in this case, I'm going to select a data agent, okay? Now, you're going to see that over here, it says build a generative AI agent that understands your data and can answer complex questions in a variety of conversational interfaces, right? Sounds pretty cool. Let's click on that. We'll give it a second to load, and then we have to give a name to our agent. So I'm going to say coffee data sales agent. Okay, let's go ahead and have that created. This is what it looks like. All right, so now we don't have anything right now in our Fabric data agent. The very first thing that we'd have to do is make sure that this agent has some data that it can connect to. So currently it says no data added. If you click on add data, you can use Azure AI Search or use data source. Now, really, you can connect to anything that's there in your Microsoft ecosystem, right? You're going to see that I've got all these semantic models. I've got lake houses. I've got warehouses. There are a bunch of different things that I can add uh, to the memory of my Fabric data agent, right? And there are multiple combinations of multiple things as well that I can add. So it can be a semantic model and a lake house and a warehouse, right? In this specific use case, I am just going to add my coffee shop semantic model. That's diffs coffee shop. I'm going to go ahead and get that added. We'll give it a minute to load, and then you're going to see that there's my semantic model. It says coffee data sales agent. Okay. And then here I've got all my tables. And if I go back to my Power BI desktop, these are all the tables that are part of our semantic model. Now notice that in this specific case, the agent would have some context already, right? It knows that the coffee category table talks to the coffee div coffee shop data table. The location tables has a one-to-many relationship with the coffee shop data table as well. And same like that. So our model really is a very well-defined, beautiful model, right? Data table, lookup table, one-to-many relationship. So a model like this is a lot easier for a data agent to know, gives more context to a data agent. We'll be talking about that context here in a second. But okay, so we've got all these tables over here. Now, one of the things that we have to do is this is our data tab. You're going to also see that we've got a setup tab over here, right? And in this case, we'd have to specify some agent instructions. So here it says, guide the data agent to the best data sources for different types of questions by writing a detailed system prompt, okay? So how we want our data agent to behave, okay? Now, for this specific use case, we don't have a whole lot of different kinds of data talking to each other as a part of the semantic model, but a semantic model is fairly straightforward to understand. Regardless, I am going to give it some more context over here. So what I'm going to say is I have a coffee shop in various locations of the United States, okay? Please follow my semantic model design to answer questions. And then I'm also going to say that diff coffee shop data is the sales data, okay? And the reason why I'm explicitly stating that is because if you're going to see a lot of these tables, they have the right kind of that kind of data that's there in the table. The name of the table really justifies the kind of data that it's holding. Locations truly has locations data. Coffee category really has the kind of coffees that we're selling. Customer name has a list of all the customers that we are engaging with or have bought coffee from our shop. Diff coffee shop data, sure. Is it sales data? Is it like another locations data? We need to give our model a little bit of more context in that. Okay. Now I'm saying I have a coffee shop in various locations. Please follow my semantic model design to answer a question. Uh, diff coffee shop data is the sales data. Okay. Now let's select all of our tables, and then I'm going to ask my data agent a question. Now this question might be the same question that our CEO wants to know in seconds. Okay. So I'm going to do this with this question here. And notice that you can also provide some sample questions over here. If you don't know where to begin, you can click on these sample questions, but here we've got our question already defined. So I'm not going to use that. I'm going to say what kind of location has the most amount of sales, what kind of coffee was sold the most at the location with the most amount of sales, and then I'm going to hit send. Okay. Then let's wait for this data agent to analyze our data and give us an answer. Okay. Now, if you go back to the architecture, this is where natural language is converted into a DAX query, since we are creating a semantic model. And then all of that is converted back to natural language and we get an answer. So our response time was 16 seconds, okay? The agent took 16 seconds to tell us the location with the most amount of sales is Austin. At this location, the kind of coffee sold the most is the latte, okay? All right, cool. Well, is that correct? That's another question that you might start to wonder about, right? Did the model hallucinate, or was it able to pick up the context correctly, write the correct DAX code, convert it back to natural language accurately, and is the response really correct? Okay, so let's go back to our Power BI report and let's do this calculation by ourselves. First, we need to find out what kind of location has the most amount of coffee that was sold. Let's do the store location over here. And then what we can do is first we find out what location has the most amount of sales. I can just do a count of customers at each of the locations. So it looks like Austin is the location with the most amount of sales. That's one. And then what kind of coffee is being sold the most? Okay. So what I can do is I can say kind of coffee and then customer name. I can do a count of that. Okay. And specifically, we are seeing Austin. Okay. So if I click on Austin and arrange it in a descending order, you're going to see that at Austin location has the most amount of sales, and then latte is being sold the most. I believe that was exactly what our data agent told us, right? The location with the most amount of sales is Austin. At this location, the kind of coffee that is sold the most is latte. That's pretty cool, right? It took 16 seconds to answer that question. Now, we can obviously write DAX code as well to answer this. So let's see how much time does it take me to write this same DAX code, and am I faster than the data agent? And how much time does it take for the data agent to write it, and am I faster than the data agent? Okay, so here we are trying to find out what location has the most amount of coffee that was sold. So what I'm going to do is I'm going to create a new table. And to make things interesting, what I'm going to do is I'm also going to start a stopwatch. Okay, so there you go. So what location has the most amount of coffee that was sold? So let's create a calculator table. This is total sales per location. And this would be a summarized table in which we are going to look at diff coffee shop data. We're going to group it by stored locations and then total coffee sold, which is going to be the sum of actually the count of div coffee shop, customer name, okay? And then we would want the location with the most amount of sales. So the top one of this based on total coffee shop, based on total coffee sold, and then descending, okay? So here we get Austin and 71 was the total coffee shop. So it took me 1 minute, 21 seconds to get to the answer. I'm going to pause it here. Now this is getting the answer and then also reporting the answer back, which would take another minute or 2 minutes. So there you have it. This was my time, 1 minute, 24 seconds, which involved manually querying the data set, writing a bunch of DAX code, making sure that I remember the different DAX statements, the syntax of everything, versus configuring a Fabric data agent and providing it a lot of context and making sure that my semantic model is configured correctly and going to the side of adopting more agentic work for questions like this. And obviously, there are so many more things that you have to think about when you're setting up a Fabric data agent like this. If you have any questions, feel free to drop them in the comments below. I read every single comment and I respond to every single comment. Until next time, thank you so much for watching Analytics with Div.